saline reservoir injection site is about 1.8 miles deep. The most cost-effective method of capturing CO2 is at the point sources, which include large carbon-based energy facilities. Industries with significant CO2 emissions, such as cement production and steel making, natural gas processing plants, synthetic fuel plants, and fossil fuel-based hydrogen production plants. Extracting CO2 directly from the air is also possible, but is more challenging and expensive due to the lower concentrations of CO2 in the atmosphere compared to emissions from combustion sources. One common approach to CO2 capture is post-combustion capture, which involves removing CO2 from the combustion of fossil fuels. One common approach to CO2 capture is post-combustion capture, which involves removing CO2 after the combustion of fossil fuels. This method is typically used in fossil fuel power plants, where CO2 is captured from the flue gases at the power station or other point sources. Post-combustion capture technology is well understood and currently employed in various industrial applications, albeit on a small scale. It is an area of active research, particularly because it can be retrofitted to existing fossil fuel power plants, allowing them to incorporate CCS technology in this configuration. Let's look at separation technologies. The major technologies proposed for carbon capture are membrane, oxy-fuel combustion, multiphase absorption, adsorption, chemical looping combustion, calcium looping, and cryogenic. The dominant technology for capturing carbon dioxide is absorption, also known as carbon scrubbing, using amines. This method has been successfully implemented in industrial applications. The leading amine used for CO2 capture is monoethanolamine solution, which has a heat capacity of approximately 3 to 4 joules per gram K, primarily due to its high water content. However, the high heat capacity adds to the energy requirement for regenerating the solvent. Capture costs account for about 2/3 of the overall cost of carbon capture and storage, which currently limits its widespread implementation. Improving the efficiency of the capture process will greatly enhance the feasibility of CCS, as the transport and storage steps of CCS are already well established and less costly.